From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
All of manufacturing is telling a machine where to do what, when. Where do you want to put the laser or the jetting head or the FDM head? How much do you want to engage it, right? Like what's the speed and feed of it, right? And of course, order matters because this is all a thermal time history problem.
That was Harshil Goel. Harshil is an inventor, engineer, and mathematician with degrees in pure mathematics and mechanical engineering from UC Berkeley. He leads the Dyndrite team with a vision of how modern software will transform digital manufacturing. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, or Amazon. Also, if you or your company are looking for materials, data management, or general additive manufacturing support, reach out to the team through our website or via email at info@3degreescompany.com. Well, thank you so much, Harshil, for joining the show today. Excited for the podcast. It's been a long time in the making.
Yeah. We've been talking for years about doing it, and for whatever reason, it's just been kind of a missed connection.
As we kick off kind of the new year, kind of similar to other episodes that we've done, we'd like to start really at the beginning. Where were you born? Do you remember any kind of pivotal time when engineering or kind of mathematics in your case kind of started to creep into what you were thinking about, what you were doing as a young child or early adult?
Okay, yeah. So I was born in New Brunswick, New Jersey, which might be kind of funny to most people. I was born there because I had parents who were teaching at Princeton. And within 3 weeks after being born, I was actually lived in Australia for 3 to 4 years in Sydney because, again, I had a parent teaching at the University of Sydney. My parent was doing all the early work in fiber optics, which is why then after Australia, we moved to California, which I spent most of my time because my dad worked at Bell Labs. In terms of, where did I start to kind of get into math or engineering? It probably actually stems from my grandma. So most people might not know this, but I'm actually a fourth generation mathematician in my family. My grandmother taught and was the principal of a school. So I spent every single summer with my grandmother, and she's the one who kind of instilled mathematics into me. And my grandfather, he owned a printing press, and he actually wrote a number of textbooks for math in India. So I'd say, I don't know if I had a choice or if the environment that was there to make me who I am started at a fairly early age. I remember doing algebra, long division, and calculus problems from a very early age. I'll put it that way.
And what itch did that scratch for you? Was it like a challenge? Was it like the fun of kind of the structure? Like what do you remember anything kind of pivotal around kind of working with, or even just like working with your family, right? It's kind of almost the family business in some ways.
Yeah, so I think in the beginning, I don't think I necessarily appreciated what math was. I think like most people, I thought it was like arithmetic or solving some fun, weird problems. And it's actually why throughout my high school time, I actually thought I wanted to be a lawyer because what I liked to do was speech and debate. And I liked doing argumentation, right? I liked knowing what the converse, the contrapositive was. And eventually I realized I didn't really care about the law. I just liked the argumentation side. And I realized, okay, maybe I just like philosophy, right? Because I like the philosophy side of law. And then when I started taking a bunch of philosophy, I realized all the philosophers I like are mathematicians or logical positivists, which made me come full circle back to why I like math, which is I think there's just a euphoric delight or joy in conquering a intellectual problem, right? And I don't think most people appreciate what math really is. It's not solving equations or anything like that. It's hardcore critical thinking, and that that kind of purgatory is, I guess, what I like to masochistically subject myself to. And that was kind of the start of it. I think the second part of that would be, I also learned kind of very early on that the scientists and the engineers that I really kind of looked up to or got very excited by were actually all mathematicians, right? And I kind of came to the realization, at least to me personally, that whenever a mathematician decides to go into an engineering or physics field, they basically become a demigod, mainly because of one specific fact. If everyone is doing science and physics with the same tools, they will only ever come to the same answers. It is only the mathematician who is the person who creates the tools that can expand out of it, right? And so I kind of built this story in my head about how I wanted to be the quote full stack mathematician. I wanted to be the person who could invent mathematical tools to then create physics equations from them and then apply them into engineering problems. And I'd be able to, through that process, be able to solve engineering problems in a way that no one else could solve them, simply because I had better tools.
Got it. So, awesome. And so, kind of coming from the academic kind of family and background, went to university. You want to talk about kind of that experience, kind of what you like, kind of how that shaped some of your thinking and your evolution as a person?
Yeah, so it was kind of an interesting path because, I mean, obviously I applied to a lot of the common colleges that you would find across the US that are kind of the prestigious ones, or the Ivy Leagues, if you will. And ironically, I visited all of them and I hated it. Right? I remember having an email and phone conversation with someone at MIT, and I asked them if it would be okay if I could skip the entire undergraduate curriculum of mathematics and just go straight into the graduate program. And the lady told me, everyone who comes to MIT thinks they're super smart, and no. Which, like, is understandable, right? Like, if I'm 16, 15, right? Through a sequence of events, my mom, who's a yoga instructor, she met a woman by the name of Tammy Kolda, who was a mathematician at Sandia National Labs. And she ended up becoming a mentor for me. And she told me, hey, you should go meet this guy named William Kahan at Berkeley, and he might convince you to want to come to Berkeley. So I dressed up in a suit and figured out MapQuest and somehow got to Berkeley and met with this individual named Dr. Kahan. If you don't know, Dr. Kahan, I found out later, had won a Turing Award for inventing floating point arithmetic.
Okay.
And he basically told me, you want to come to Berkeley for one reason and one reason only. And that statement, I've actually shaped my entire, I think, life, to be honest. He told me that you want to learn through a process of something, what he calls casual confusion. He said, Berkeley is the only place which will not put handcuffs on you on what classes you can take, because it's so liberal, it gives you the freedom to fail. And he said, what you need to do, Harshil, is you need to take a double or triple class unit load and overload your brain so much that when you're doing and solving problems that you forget which class you're in. And through that casual confusion, you'll start to apply concepts and ideas from other classes and build up a unique repertoire of how you go and solve problems. So that kind of really resonated with me. It's why I decided to go to Berkeley for bachelor's, master's, PhD. And to give you a sense of it, the first semester of Berkeley, I basically took the entire mathematics undergraduate curriculum in one go. So it was Math 53, 54, 55, 104, 113, and then Physics 7A. By the way, all those classes are prerequisites of each other. Right, which is something I was told would be illegal at MIT. And it was I basically just did that every single semester at Berkeley for years until I was so casually confused with what I was doing. I think I kind of developed my own unique approach, which is this, this kind of full stack approach between mathematics, science, and engineering. But yeah, my degrees at Berkeley are in pure mathematics and mechanical engineering, with a specialty in differential geometry and differential topology. and on the mechanical engineering side, continuum mechanics and computational fluid mechanics, which is a long way of saying I'm a real big fan of Bernoulli and Euler and Gauss.
And so talk about the mechanical engineering part. I mean, I'm curious as we kind of get into the conversation a little bit more about, I mean, you spend your day now kind of enthralled in the manufacturing space. Where did that kind of root out? Were you kind of looking, you kind of mentioned before how you wanted to kind of bring your mathematical approach to engineering problems and engineering disciplines. Did you have a target in mind, whether that's like an industry or a specific problem or material?
So like it was all honestly by happenstance. So as you're probably realizing, I'm probably also one of the most unhireable people on the planet. I have some stories about how I failed my Apple interview and my Ford interview. And it was out of pure just desperation that in college I ended up working at a wind tunnel. And I came up with a new way to do boundary layer control, having never learned fluid mechanics before. That's actually how I started my first company, Barres. And that didn't necessarily go the way I wanted to, but in that process, I made a bunch of friends at Boeing and across the industry. And it was those friends while I was in my PhD program who came to me and said, "Hey, additive manufacturing is really cool, but software sucks." So these are some guys at Boeing. And so they were like, "Hey, Harshil, you kind of have this unique repertoire of coming in to an engineering field that you have zero idea about and abstracting it and thinking about it in a different way using some different math tools. And maybe you can use that methodology to see if you can unlock something in this industry." So I got into additive not because I necessarily had an affinity for it or no metallurgy or lasers or anything like that. It was literally just an interesting set of math problems that a couple of guys I made friends with at Boeing wanted me to solve. And that was it. Now, of course, I stayed because I got excited about a bunch of stuff and honestly infuriated by a bunch of stuff. But yeah, I never actually came into additive trying to solve anything in additive, like specifically or with like an affinity for it or any specific industry. That said, I had a bunch of friends at SpaceX and Blue Origin. It's why our logo is a rocket flame, by the way. Our first PO came from one of those companies. And so obviously I saw a lot of fluids problems to be solved, but I never actually came into it with any specific goal in mind in that sense.
And do you remember, I like asking people this question, do you remember the first time you saw a 3D printer or kind of the technology?
Yeah. I think the very, very first time I saw the technology, but I didn't really appreciate it back then, was actually when I was working in the wind tunnel in India. And I had to print some airfoil and with some complex electronics in them. And it was a Stratasys FDM machine. I didn't know it was additive. I just went into the machine shop and was like, "Hey, making this airfoil on a Bridgeport or a CNC machine," which is what I was used to using, didn't really make sense. And this guy was like, "Hey, we got this new machine thing and it might give you the shape you want." I was like, "Cool, whatever." I don't think it even clicked when I did it. It was just a means to an end to go solve this aerodynamics problem.
Yeah. And one thing I noticed on your LinkedIn, I want to come back to kind of your entrepreneurial journey as well. But you did Engineers Without Borders for a couple of years. Do you want to explain kind of what that program is and kind of how you found it?
Yeah. So Engineers Without Borders it's this kind of philanthropic program where folks work with other communities all across the planet and see if they can find a solution to an issue that they're facing. Right? It's all kind of like donated time, volunteer, right? Like it's a nonprofit type of thing. And I got interested in it again just because I saw some interesting problems. So when I was doing Engineers Without Borders at Berkeley, I was in charge of one key aspect, which was there is a arsenic problem in a lake in Peru, Lake Titicaca. And the objective was to see if we could develop a new type of water filtration system to help the residents near and around the lake in a very low cost, cheap manner, so that, well, arsenic poisoning is a horrible way to go. So yeah, it was like a cool, interesting problem to be solved. And I always, of course, like solving problems which actually help people, and that problem kind of spoke to me. So that's how I kind of got involved with engineers about borders while I was at Berkeley.
Okay, that's awesome. What was the biggest thing you took away from that?
There's a lot of other things besides engineering problems that start to matter. So, for example, our initial design, I think, was using limestone to help with the filtration of that arsenic. Turns out that's a very controlled substance in Peru because you can use it to make cocaine.
Yeah.
It's not a thing that anyone in a classroom in Berkeley would be thinking about if they're designing a water filtration system, you know, and limestone is a key component, right? So I think one of the things I learned was there's more to the engineering process than the specific science or mathematics at hand. There are some other kind of human factors involved, and that was kind of, I don't know, it was eye opening to me because I just wasn't even thinking about it, you know.
Yeah. So now, kind of laying the scene a little bit, kind of coming back to kind of your startup entrepreneurial career, kind of walk us through some of those early days of Dyndrite, and kind of, we know where the logo came from at least, but kind of talk us in a little bit more detail of kind of what the origin story there was.
So I started Dyndrite when I was doing my master's PhD program at Berkeley. I was mainly doing my master's PhD program at Berkeley because I needed a part-time job to do
Sure.
something until I figured out
That's
my
the
next.
reality. Yeah.
In fact, my advisor, Philip Marcus, he during my some of my defenses was like, "You should not stay here." So, by the way, I'm on indefinite leave of absence still, technically, from Berkeley, even though I passed a number of my exams and classes and whatnot. So while I was doing that, a couple of my Boeing friends hit me up, and they said, "Hey, can you solve these design problems and these manufacturing problems?" And so the first year and a half of Berkeley were me going to a coffee shop called Cafe Strada in Berkeley and just sitting there with a laptop and prototyping some code in MATLAB because that was the only programming language I knew at the time. By the way, I also taught the MATLAB programming class at Berkeley. I had a friend named Jeremy Fiance, who's a startup incubator and VC friend who I've known also through since college, and he used to let me just hang out on his couch and just work on some problems. In that process, I started to solve some interesting problems, and I then basically, through a sequence of events, ended up cold emailing some folks at SpaceX and Blue Origin. And one of the folks at Blue, Steve Walton, he responded and basically said, "How the heck did you do this?" And that spawned me just going to Seattle and seeing him, and that's how I met Steve. By the way, Steve's our head of product now.
Okay.
But he was at Blue, I think, 10 plus 12 years. I mean, he was in propulsion, led the in-space propulsion group, started the additive group at Blue. And my first visit to Blue, I met with him and actually Tim Ellis. I don't know if you know Tim as he ended up going and starting Relativity.
Yep.
And we started working on this problem from a design perspective. And I realized that, well, we both all collectively realized that the issue wasn't designing the part for the machine. The issue was getting the machine to make it. Mm. And that's actually what led me. Steve is the one who introduced me to EOS, for example. Like, I don't know how he was making those rocket propulsion parts, but he was like, "Hey, I need to go make it on these EOS machines." And that's kind of what really started that journey. I basically just cold emailed a bunch of people with some ideas that I had, the problems I could solve, and slowly just kind of built a cabal of people who I guess wanted to join me and help solve those problems.
And what do you mean by kind of teach the machine how to do it? Do you want to kind of explain what that meant at the time and kind of what it means now?
So it took me a while to really refine it into like one maybe succinct, pithy sentence, which is all of manufacturing is telling a machine where to do what when. Where do you want to put the laser or the jetting head or the FDM head? How much do you want to engage it, right? Like what's the speed and feed of it, right? And of course, order matters because this is all a thermal time history problem, right? And so if we combine that with the statement that the manufacturing hardware has surpassed the software, what you really come down to is you realize that these machines are capable of a whole heck of a lot of really cool stuff. The only thing that's really limiting them from a productivity, quality, surface finish, etc. standpoint is just the software telling the machine to do print stuff in a much more clever way, right? In fact, that's through the conversations I ended up having at SpaceX, I came up with this concept of volumetric segmentation, which is actually an idea that I ended up pitching to Benny and Tasso in 2017. By the way, after I pitched it, Benny offered to buy my company the next day. Obviously, I said no, but it's a small world, and yeah, it's did that answer your question?
Yeah. And so you're kind of looking at kind of 3D printing in detail. You've got some kind of initial customers slash users slash collaborators. When's the kind of what's the next stage like that you view as kind of the iteration of the company? Do you have kind of a product that you ended up like, hey, okay, now we talked to a bunch of people, we talked to the OEMs, we've talked to the users. Here's where I can kind of nest and kind of build out some deeper functionality, deeper product, whatever that may be. Like, what was that evolution like when you started?
In all honesty, all the laser powder bed fusion people back in those early days, 2017 to 2021-ish, wanted nothing to do with me. I was a thorn in their side, right? Like telling me to F off might be a generous way of saying how they wanted
like the machine manufacturers, you're saying?
Yeah, okay. All of the laser powder bed ones.
Yeah.
But in that, there was kind of this interesting diamond that kind of stuck out, which was HP. HP had just reorged. They had created this new kind of 3D printing, personalization division. And a couple of guys by the name of Ryan Palmer and Anthony Graves saw kind of the opportunity here and saw that the limiting factor for all the HP machines was the software and said, hey, we want to partner with you guys and make the universal build manager, right? That's probably a product that you've heard of. Yep. It was supposed to be the next CAM tool for additive. Right. Now, that didn't necessarily go the way it wanted to go because less than 2 weeks after I signed agreements with HP, COVID happened and a bunch of other things happened in the industry. But it ended up leading to us still developing those tools, developing laser powder bed systems. And the next big jump that happened was SLM revealed the NXG. So they sold the NXG to a number of key customers, which you can look up, which I can't name. We helped those customers do some really fantastic things. And that got SLM to perk up and realize, oh, crap, this NXG can be turbocharged and supercharged in a number of interesting ways. And this software could actually start to help in a number of ways. And that's what kind of started the next wave. I think it was kind of a stars aligning moment because in retrospect, the problems that we were solving exist for all the machines, but they were sort of exacerbated by such a large and complicated machine, right? When you have 12 lasers doing something, you probably want them all to be productive, right? And so all of those toolpath type things kind of just magnified. Secondarily, I've been on the NVIDIA Developer Council for, I think, 6 or 7 years now. I made a prediction that every 5 to 10 years, the build volume or resolution would double, basically. And right when you hit that NXG size, that's when the computer that you're running all your software on starts to really matter a lot, right? It became a computational bottleneck, right? Where Sam O'Leary, he said at one of our conferences, it takes longer for people to prepare the data for the NXG than the NXG to print it. Right. And so that's I think what the next kind of flipping moment was just this new class of machines coming out, honestly, in the last 3 to 4 years, and people hitting all the software bottlenecks that I was expecting them to hit imminently. And that's kind of what changed our fortunes in some regards.
And so what's kind of your perspective on the OEMs are building the machines, obviously, right? So they're trying to do some material science, they're trying to do some mechanical engineering, manufacturing engineering, and in my sense, the software is always like the third or fourth thing they think about. Mm-hmm. Is that your experience too? Is that like they just don't have the teams, like it's like a secondary, third kind of
I think it's
priority? What do you think?
I think it's a cultural thing and a mismanagement of expectations, right? So, certainly the hierarchy right now is machine, materials, and software, right? I think culturally, as mechanical engineers or Germans, maybe we might value the thing with the most mass as opposed to the ephemeral thing, right? Yeah. So just culturally, as like a tactile thing, the heavier it is, the more it must cost, of course, right?
Yeah.
So
you can show it to people on a tour, your machine, right?
Right, exactly, right? So that's one aspect of it, right? The second is software actually means two different things. And I don't think most of the machine manufacturers have an appreciation for it. Software is the closed loop control system on the machine. It's the controller, it's the firmware, it's all that jazz, right? Which is what most people think about as software in the hardware space. But then there's also the front end of how do you interact with the user, which is a totally different group. And that's the group that's usually very underfunded, right? The second aspect of it is, I actually do think that there is a place for all the machine makers to develop software and actually monetize it. It's just a question of where's the interface? Like, do you really need to reinvent, 80% of the car? Or do you really want to only focus on the 20% on the very top, which is actually where your material science and engineering IP are, right? And I think we've seen this in a variety of the companies in this industry. There's a lot of non-invented here syndrome, where everyone wants to just kind of vertically own everything. And unless you have a lot of money or a lot of, honestly, discipline, it's a tall order. So yeah, I don't really envy the machine makers, right? They're always going to be told their software sucks, right? No matter what they do, right? And it's just a question of how do you manage those expectations? That said, I do get frustrated when machine makers make software that can barely make the part to get onto a form next floor and market that as their software solution, right? Mm-hmm. I think there's a little bit of underhandedness going on in our industry in that regard.
Sure. And so kind of going back to your journey as a founder, I mean, over the last, it's almost 7, 8, 9 years now. Yep. What are a couple of the key lessons, key takeaways as you've kind of built products, built teams, interfaces with customers, navigated a pandemic? Are there things that stick out for you in terms of how you approach kind of business or leadership?
I think that the key is to have a lot of conviction in your goal. I think a lot of people have tried to sway us from what we were doing over the last 8 to 9 years. And I honestly question myself every day whether or not we're building the right thing for the right reasons, in the opposition of a ton of people. Like a ton of people literally have told me, don't build this. Right? And so I think it's important, if you're an entrepreneur, to have a lot of conviction about what you're doing, and to be honest, being an entrepreneur probably requires you to have a little bit of a mental illness to have that much, honestly, conviction. I think the other bit is you never know how it's going to go, right? I thought I had a very straight line path where I would show people how awesome something is. They would get super excited by it and then say, okay, let's go do this. When it turns out there were a lot of other hidden things going on behind the scenes. various relationships and kickbacks, various cultural issues,
Oh.
qualification issues. There's all kinds of other stuff that's going on besides the technical side. And so, yeah, I think that's the key learning that I've had. It's to sit back and listen a lot more than talk, if you will, to understand the problem a little bit better, because it's usually the third or fourth meeting where you actually figure out what's actually going on.
Yeah. So just a couple more questions. So one is, at the start of the year, 2025, what are you excited about, either personally, professionally, with the company, going into the new year?
I think this could be a really cool, explosive year for additive. I think a lot of the things that were going wrong in the industry are thankfully burning to the ground. I think the people who are investing in machines are getting a lot more mature. And like, to give you an idea, I'm getting people who told me various features of my product were completely complicated and unnecessary. In the last week, every meeting I've had, they told me that the reason they want the product is exactly those features. Right. So I think I'm most excited about the maturity by which people are approaching these problems, and that we can finally get away from this slog maybe that we've been in for the last 20 to 30 years. I think that's the part that excites me. I'm also excited about a number of technical achievements that might be hit in the next year or so, which I don't know if I can necessarily talk about, but let's just say I think everyone thinks qualification sucks. And I think there are ways to accelerate it, and there are scientific ways to accelerate it. So those will be kind of big deals. And people are going to do even more cool stuff with some of these big machines. I have insight even into this first week about the kinds of parts and things that people are trying to make, and they're doing some insane stuff. Like, they're using our tools in ways that I never even thought of, and I go into every customer meeting and I basically learn something new. This is the way I would put it.
Awesome. So last question, kind of more of a fun one. Last year we put out a book list of kind of recommendations from our podcast guests of books that they found helpful over their life and their experience. So what would you like to add to start this year's 3 Degrees discussions book list? What's your favorite of yours, or something that you've read recently that's made an impact?
Yeah, I think two books that I've read recently that have made a real impact are the Soul of the Deal by Mark Morgenstern. He basically goes through his life lessons of deal making throughout the entire book and gives all these anecdotes. And I think there's a lot to be learned from those anecdotes. The other one is, I actually have the book on my desk. It's called The Ends, and it's by Garrett Cordone. He's actually one of the salespeople he's the leader of North American sales at SLM. And he's also written a book about his life perspectives and what he's done and how he's done it. And I always like reading books and getting feedback and knowledge. So I'd say those two books.
Awesome.
Soul of the Deal and The Ends.
A good way to start the year. So we'll have a good list this year. Awesome. Well, Harshil, thank you so much for joining the show today. Really thankful for sharing your story, and excited to see you on the circuit, I'm sure, sometime this year.
Yeah. Well, I think the funny thing is we'll be doing the circuit a little bit different this year. I think Sean will make a press announcement about it shortly.
Yeah.
But yeah, I'm excited. I'm excited to see you, Mike. I'm excited to hopefully work with you. And, if people are curious about doing materials and process development, they know where we're at. So thank you for the opportunity to be on your podcast. I appreciate it.